Welcome everyone. Today we'll discuss how to test the fault tolerance of the ElastiCache cluster you're operating, as well as the connected application or clients, and how to monitor a test called a chaos experiment. We will explore the benefits of a chaos experiment and the process itself, and address common questions our customers have when encountering a failure in your in-memory workloads. So, what is chaos experiment and why should we do it? Chaos experiments help to confirm whether a system is fail-safe and has resilience by injecting load or faults into the system within a controlled environment. Failures are certainly something to be avoided. So what's the reason for intentionally injecting faults and checking reactions in advance? The obvious reason is the potential cost of downtime. According to estimates, 91% of enterprises face over $300,000 per hour of downtime, with 44% hitting $1 to $5 million per hour. Businesses facing regular outages pay 16 times more for recovery compared to those with less downtime. Downtime risks compliance issues, stock prices, even business failure in extreme case. Furthermore, most modern systems are composed of distributed systems. Distributed systems are complex, so when we actually encounter failures, it's very difficult to identify the actual root cause, starting from the unfamiliar phenomena. This is why simulated failure training is necessary. AWS provides a service called Fault Injection Simulator that allows you to conduct resilience testing. Resilience testing with AWS FIS is necessary for the following reasons. First, it can improve reliability and availability. Second, it can uncover hidden issues that we are not aware of beforehand. Third, it can help identify gaps in our team's response procedures. It allows us to assess various aspects such as monitoring, observability, alarms, and logs. Finally, it enables us to enhance our failure-related runbooks and playbooks. Resilience testing is not a one-time activity in systems lifecycle. It's necessary to continuously identify areas for improvement and refine the team's response procedures through the following steps. Modern systems evolve and change constantly, much like living creatures. The teams operating these systems must also adapt these evolutions, and they need to periodically conduct resilience testing to maintain visibility into potential failures. Okay, now let's look at an example of fault injection. For a system configured with multi-AZ, we can inject a fault that simulates a power interruption in one of the AZs. The following is a typical multi-AZ architecture. Using AWS FIS, we will inject a power outage fault in one of the availability zones. This is result in the application being used only in the right AZ, and ElastiCache and RDS will be promoted to primary. Once the fault is induced and availability is reduced, an alert will be triggered. And the ELB will start processing traffic only from the right AZ, allowing the service to be served from that AZ. This is the desired recovery process for our system in the event of an AZ failure. In this demo that I will explain later, we focus on testing ElastiCache and its connected clients as they are critical components. So, as shown in the diagram, we will use FIS to inject an AZ power failure into the ElastiCache cluster and observe how the cluster and its clients respond. Before that, let's run about the Valkey Glide client library that we will use for the experiment. Valkey Glide is an open source client library maintained by the Valkey open source project. It's compatible not only with Valkey, but also with Lattice. Also, if you look at the high-level architecture on the right, you can see the core logic is implemented in Rust, and it's wrapped to provide client drivers in other languages. This architecture allows you to use the high-performance Valkey client library in Python, Node.js, Java, and Go with the same core logic. We will use the Valkey Glide client library as application for the chaos experiment. Okay, let's proceed the chaos experiment for ElastiCache. First, let's take a look at the Valkey Glide code installed on the EC2 instance. The read.py reads from the read replica for random keys, and the write.py writes random string keys to the primary node. The two codes are not significantly different, except that they use get and set commands, respectively, and the read strategy is set separately. In this demo video, the client is running on only one host, but in a real environment, the client will be running on multiple hosts. Therefore, it's a good idea to use AWS System Manager along with scripts like run.sh and info.sh to automate the process. Let's start the reading and writing using the scripts. The clients are running normally, and we can see the logs being generated. Next, let's check the ElastiCache cluster. The cluster consists of 3 shards with 2 replicas per shard and uses a total of 3 edges, A, B, and C. Additionally, we will use FIS target tag that has been entered to control which clusters the value is injected into. This tag is used when creating experiment templates in FIS. We will be injecting a value into availability zone C, and the isMaster metric shows that the node 1 of shard 1 is in availability zone C is a primary. Therefore, I will soon check the engine logs of shard 1 through CloudWatch logs. Now, let's create a template for chaos experiment in FIS. In the description, enter Valkey chaos exp and click the next button. Then, click the add action button. For the name, enter outage and select the ElastiCache. Interrupt edge power action type. Keep the duration at 5 minutes and click the Save button. Select the target and enter the FIS target tag that was on the ElastiCache cluster earlier. Also, set the age to C. If you need it, you can configure IAM role and the termination condition, report generation, and logging settings. We will skip those for the demo. Finally, review the conditions and create the template. In 1 to 2 minutes, the template for the experiment generated. We will proceed with the experiment using the template. Start the experiment by clicking the button. If the experiment status has changed to running, now let's check the status of ElastiCache. If the ElastiCache cluster status is modified, the experiment is progressing normally. Approximately 2 minutes after the experiment started, let's check the metrics of ElastiCache, such as CPU utilization. We can see that metrics of the nodes in availability zone C are not being collected. Next, let's check the logs of Valkey Glide on the EC2 instance. During the failover, we can see that the keys on the nodes in zone C experienced timeouts, but then started functioning normally again. Finally, let's look at the engine logs in CloudWatch logs. The primary node of shard 1 was impacted by the age failure, so the other nodes of shard 1 detected the connection failure with the existing primary and performed a failover to select a new primary node. Today, we've conducted chaos experiments using AWS FIS. Through this experiment, we've observed how clients like Valkey Glide operate, checked the cluster's engine logs, and identified the metrics that needed to be collected for monitoring. As demonstrated in the demo, chaos experiments help us anticipate what may happen when failures occur, and consider how to identify and address such situations. If you have become more curious after watching the demo, you can refer to the following materials. Hope this video is helpful and look forward to your questions. Please feel free to reach out to your account teams if you have any more follow-up questions on the chaos experiment for ElastiCache. Thank you again.